Now remember that we have the boil-off, so in your economics you have to consider a boil-off. But you don't know exactly how your LNG is going to boil off. It will depend on the age of the ship, but it will also depend on the sea conditions. Imagine now if I pour some LNG inside here. If my tank is spherical and I'm doing like this, the liquid is not really banging against the walls of the tank. This is called sloshing. So it maybe creates a little wave on the side, but it's not really triggering a lot of evaporation. But in fact, you have two kinds of vessels, two kinds of containments. You have the moss and the membrane. A moss vessel, you put spheres inside the ship. If you do this, you see that you waste a lot of space. So what's the result? The ship is bigger, higher. Maybe in some ports it cannot enter the port because it's too big, or they cannot moor it. But not a lot of sloshing. Membrane, you carve the tanks inside the hull. So a membrane, if you look at this cross section, would be something like this, with the ship being like that. Then you can imagine that the sloshing in that case is much worse. So if you're crossing Cape Horn, maybe you save the port costs, the pilot costs that you would have incurred to go to Magellan Straits. You don't have to go around the Cape Horn. You can go to Magellan Straits, which is like a fjord. But if you have very big waves, maybe during 3 days, you will lose a lot of boil-off. And a small percentage of a huge cargo makes a difference. So if you have waves, it increases. If you have also a short load, so if you decide to have a partial cargo, then there's more evaporation. So in our economics, we just consider 0.15% per day times the volume. But I think there's a formula that's a bit more complicated. It takes into account if the tanks are full or not. And actually, you have also tables that are provided by the ship owners that can guide you through that.